Why is it pending? Okay, great. Okay, so it is so the recording is in progress now. Yeah.
Yeah.
If you want and if there's no bandwidth issue, then you can disable your video. Else is fine. Yeah.
Okay.
Okay, so let us do a standard style to ATP conversion. So I'll go to so some of the commands are very local to Synopsys, so it might not be specific. For example, module load VTRAN is to just load the latest VTRAN uh, version. So for your case, it might be different, I'm sure.
Mhm.
Okay.
Yeah.
So yeah, so for example, the VTRAN version, what I'm using uh, is S version. Sorry. Is S version S2021-06 SP5, which is the latest version. So, but for this conversion, majority of the recent versions are good enough until and unless you have a identical block. Okay, for example, if you are having identical blocks and if you have generated pattern on one block and you want to use the same pattern for multiple instances, we need the very latest version.
Okay.
Okay.
Yeah.
If you don't have identical blocks, then we don't have to worry about it.
Okay.
Okay. Okay, this is a recent fix what we have done. So just giving an update. So so one thing what to start with style to ATP conversion, one thing what we can do is we can use an existing configuration file or write the configuration file from the scratch. Okay, but
Mm.
generally user may not have a lot of background on how to write a configuration file. So even for this, the VTRAN has an inbuilt feature which will take user inputs and it will write out a standard config file, a standard configuration file, which will have majority of the most used variables already set in. So how do we actually use it? Okay, so there's a tool for it. Uh, 1 second. Just a second. Hold on a second. So you can see the screen, right?
Yeah.
Okay. So I'll get another terminal. So along with the VTRAN installation, we give some more packages, some other tools as well, which is very useful to check out how your files are looking like. Some of the tool which we can use is one of the tool which we can use out of it is called VUI. Okay, from
Mm.
VUI we can take input file and what file we want it to be converted. In the screen, if we can see, we can give the input format and the target or the output format. And it has various sections, and those sections will help in setting up how you want your conversion to occur, and it has some predefined settings which are already provided. So user don't have to worry about it. So this is the best way to start. And then some fine tuning we can do as needed. Okay. So
Okay.
for example, we will give the input format as style.
Mm.
So style we will give an input file name, file path it will need. So I'll just get a style from somewhere. Okay. For example, I'll get it from here. So this is one sample style file which follows the IEEE 1500 standard for style. So this should work. I'm like uh, for a standard input style. So this is fine for a standard input style. So this input path we can provide. So a sample input file we will give. This ST8 action file is for ST8 format, which is not for which is not the uh, a, uh, ATP format, so we can ignore it. Now target. Oh, this is Teradyne. Yeah, yeah. So ATP would be Teradyne based,
Okay.
and we will give one output. Yeah, so Teradyne files has the extension as either Flex or ATP, where you can see the TP file. So we'll give
Mm.
some output like sample output one, for example.
Okay.
And timing file, the Flex timing file also we can give a standard name, sample output timing.
Mm.
And any description if we want, that is fine. Like something to remember by. Uh, Ignore empty groups in the sense any empty set of pattern, we can ignore it, but it's fine to have it. So if we have turned it off. So for
Okay.
example, if we have like sample style file, example, this vector, this is an empty vector.
Mm.
Okay, so this instead of ignoring it, it will keep it. The VUI will keep it. So it's best to keep it so that we have a good the length of the pattern, the runtime of the pattern remains same. Okay,
Okay.
so we go to the next. Okay, so then comes the OVF block, OVF or the original vector format block. In this in OVF block, in the original vector format block, we specify a lot of things regarding the input file, like what kind of uh, settings or what kind of variables we need to use in this file. So whatever files we have provided, like sample style, which is an input file, and output is the flex format, it's already provided. The input format is cycle as well as target format is cycle based. Otherwise, the target format can be event based. that means test bench base as well. So the input format and target format for style and Teradile are here. Now, majority of the parameters are there, and the standard settings which are best suited for style to flex conversion are already uh, filled in. It's like it's a cycle base is on, scan based is on, scan based in the sense all the scan related parameters, the DFT related parameters would be
Yeah.
provided in the output file. Okay,
Okay.
for example, the test setup sequence, the waveform table. For example, if we see the waveform table, TS1 is the waveform table.
Mm.
This waveform table. So these are preserved in the output file, which is needed, which is required. Uh, and in case of any specific fine tuning, so all these user can choose to select or not select. So
Mm.
that comes with your that comes in you that comes from your side, from the customer side, from the user side, how they want to do. So for example, uh, uh, like pseudo names, it can be ignored or not. Similarly, expand loops, generally I prefer it to turn it on. Expand repeats, prefer it to turn it on. Similarly, annotations we can keep. uh, um, then pass all comments, that is fine. Header, labels, pattern execution, single pattern. These are so these we need not to worry about it. Some until unless very much required. Uh, if we have any BiDi name, then we can fill it up. So we basically we can uh, So basically, we can get more details regarding any parameter from the documentation that what it does, and based on the requirement, and we can start filling it up or not, or just leave it out.
Okay.
So uh, if we go forward, we go to the procedure block, the proc block, where we define like some of the mostly the transmission state, but we'll come to this transmission state. In process block or the proc block, we do some modifications like if there's no need for some pins or some signals in the output pattern, we can add it or we can remove that pin. We can delete that pin or we can add that pin. Similarly, uh, what is the don't care value? For example, in style file, the don't care value is X in general.
Mm.
Similarly, the don't care value is also X in the output flex file or the ATP file. But in some of the format, the don't care value can be something else, can be D, okay, can be T or can be Z. So so user has to change it as per its own requirement. Okay.
Mm.
So that comes on user. Yeah. Similarly, if there's any cycle shift commands or insert commands or any repeat command, so those user can give. Any pins they want to mask it, for example, from the output. So that mask pin name you can give like some pin if user want to mask it. Say I want to mask the reset pin. So I'll just give that reset in here. In the output command, this pin will be masked. It will be masked with X. Okay. So
Okay.
there will not be any toggling here. I'm like, we will see an X here. It will be masked.
Great.
It won't be stored. So we will see it in the output pattern.
Okay.
Uh, then comes the important part, which is the state trans table. Okay. So what it actually does is it will tell that in input file, the value in input file, the highlighted value in input file, what it should be replaced with in the output file. For example, this X that
Mm.
remains same in both uh, input style and output flex format. This
Mm.
L L may or may not remain same. This L may not be understood by the flex format. It has to be replaced by small l. Okay.
Okay.
So
Hmm.
this kind of conversion we need to provide. So for example, for all the input ports, if if the tool finds an U in the
Hmm.
input style file, if the tool finds U, that means up, it should
Hmm.
replace it with one
Yeah, in the flex file.
in the flex file. Yeah, yeah.
Okay.
Similarly, B, in some of the style standard, B is also acceptable as bold or as high. So it should
Hmm.
also understood as one. Similarly, down should be replaced with zero. A is an annotated value replaced with zero.
Hmm.
N is some like don't care value, so it is replaced at zero. Similarly, if there is no value, safely it will to become safe, it will replace it with zero.
Yeah.
Similarly, a Z input port, Z on input port does not make any sense. It's a
Hmm.
tri-state.
Try straight.
Tri-state is at output. Yeah.
Hmm.
So a Z at input state is an invalid value. So we replace it with zero. Okay.
Okay.
Similarly, all the states for in pure input or bidirectional input, similarly pure output and bidirectional output. So that user can choose. The current specified is the very standard one and it's mostly used. But in case you have a very specific changes or specific requirement, so user can edit and then go. User can edit it and make that change here.
Okay. And will this change be visible on the dot flex file, right?
Yes, yes, yes. If
Okay.
instead of say, for example, instead of uh, say pure output, okay.
Hmm.
Say for example, if I change this H,
Yeah.
if I change this H to Nadine, okay, so it will replace all H to Nadine here.
Okay.
Okay, but like, it's not correct, obviously. I'm
Hmm.
just giving an example.
Yeah,
Okay.
I got it. Yeah.
Similarly, say a tester guy comes and say that, hey, this flex file is an incorrect, flex file has an incorrect character. So it should
Hmm.
be replaced with X. So here, this is the place where we need to make these changes.
Okay. Yeah.
So this is pretty important because all conversion happens because of this. So this is a very important procedure table. Okay.
Okay. Hmm.
Yes, we need to be careful. Yeah. So yeah, output timing is fine. Generally, we don't worry about it a lot.
Hmm.
Uh, if we go ahead next, we should come to the timing block, the the TVF block. TVF block is the target vector format block. That means what is the output format file. So there we give that flex file. We have already, it can be like flex or ultra flex or J flex or whatever is the user requirement. So the
Hmm.
standard is microflex, but if you have if your Teradyne testers has a very specific format, so that ultraflex or iflex we can use. So
Okay.
it's just the file format majority, but the format remains same. Similarly, remaining parameters are pretty standard. User needs to change it as per requirement based on like whatever documentation we look through and read through. So we'll just let it be standard for now. No change here. Uh, yeah, these are pretty standard, but based on requirement, we can change it. But as of now, we don't see any need to change. Say one important is merge bidirects. So for example, if there's a bidirectional port, say in paint, uh, okay. So based on say a bidirectional port, based on the value at the tri-state signal, uh, say it has 1 over input and it has Z here. Okay, so based on this, uh, uh, based on this sequence from left to right, what gets priority in the output format, in the output file. So for example, this port at some point at say time 1000 ns, say for example at time 1000 ns, the signal, this bidirectional port has both the signals 1 as well as Z, but the output should remain only one. There should be
Mm.
only one output. It cannot
Yeah.
be two output. So
Mm.
based on this uh, priority sequence, the sequence is defined. Say for example, if the input has one and one side has one and another side has Z, so one
Mm.
will get a preference.
Okay.
Similarly, if one side is 1 and output side is H, 1 will still get a preference.
Mm.
Similarly, between H and Z, H will get the preference.
Okay.
And the output in the output flex file, the H will come up. The H will be reported.
Okay.
So remaining are pretty standard. So based on need, we can clarify it or we can fine tune it.
Yeah.
So after TVF block, we will see the config, how the config looks like. This is the preview file. Uh, we can directly make edits over here. Uh, like uh, if anything you want to add it here, we can directly add it, or we can go back and make that change as well. No difference. So
Uh,
this
like we have to add some parameters. Like if you want to change something or add something, we have to write it over.
yes. Yes, yes, yes. This is a config file, the preview of a config, and we can save that config file. Okay, we can
Mhm.
save this config file into an output file as well. And we can make that output, we can make direct changes to that output file. Yeah. Or if you want, we can do it from the scratch itself as we feel comfortable. Yeah. So for example, we have masked that pin, right? Reset and we had masked, so it has added here. Yeah, don't care was X, so that is added. Similarly, the trans states, what were the trans states? So these are the trans states.
Okay.
Yeah, then there comes the target vector file. So these are the standard configurations, what has already been provided. So
Mm.
we will save it and then we will also run it just to
Okay.
see how does it look like. So we'll just do that sample.config and save it. Okay. And let's run VTRAN and see how the file looks like, how the output file looks like. So it's running.
Okay, so we have to do this process in converting like anything like from dot still to VCD and from VCD to ATP and all that thing, right?
Yes, yes, yes. We can either convert it through this GUI table, or
Mm.
we can convert it directly through the command files. We will run it and the command file as well. Okay, we'll both we'll see it. It does the same thing, no difference.
And one more thing, Nadim, like if
Yeah.
when we are converting VCD to ATP, we get two files like VCD and time set also.
Yes.
So how we handle both of them here?
Uh, Hold on a second. Okay, that's okay. So when you convert VCD to TV,
ATP. Yeah, I don't like I don't exactly remember, but we get time set file also somewhere.
okay, okay, yes, yes. So in the ATP file, we will see the timing files are also getting sourced.
Okay.
Okay. So it will automatically pick it up in the from the same location.
Okay.
So we see the conversion is completed successfully. There's no error detected. output file is this. So let's check how the files are looking like. Okay, we'll
Mm.
just close it. Let's minimize it for now. Okay. So for example, let's check the flex file. Okay, so yeah, this is a standard flex file with all the input ports
Mm.
and the many ports. Yeah. So yeah, and it has done the successful conversion. We can see the pattern starts here. Uh, we'll do a visualization as well. We'll check it. How does it looks like? Okay,
Mm.
and I just want to see that reset n. Yeah, this was the port, right? Reset n, which we had masked.
Yeah.
So if we see, it is actually at the first bit. The first bit is reset n. Okay.
Mm.
So let's check in the pattern. What is the first bit? First bit is 1. That's a test setup. Okay. Okay. Let's check in the DFT view. So there's another tool called DFT view, which will help user to take in two files like uh, the input file as well as output file. They can take and they can do a direct comparison and
Oh.
see from where the changes are actually happening. So for
Mm.
example, DFT view if we open. Uh, Sorry, here it is. Okay. FT view, I'm going to invoke, and we can use both the first in the format of the command is that the tool name, the first file, the second file, similarly third file, fourth file, fifth file, etc.
Mm. Okay.
So this input style versus flex will take. It's a little slow. Okay, I'll just close the VUI. So it will load uh, wordy. It will to display the graph. It will load wordy. So if you don't have wordy, then N wave by default it loads. So that is something which both which it should have here. Otherwise, you can provide the path of the N wave installation. It will automatically ask.
Okay.
I should load the second one as well. So yeah, let's pick up the correct files. So we would basic timing file. The ESET file and TSET file. Okay. Why is not opening it? Just a second.
Yeah.
Okay. So so here in the screen, we can see the DFT view versus DFT view style, that's input style, the OVF file versus the target file, the flex file. Okay,
Yeah.
how does it looks like? Yeah. So, for example, we can do a direct eye based comparison, like how this clock is looking like. Uh, uh, Similarly, how any other signal, how signals of your concerns are looking uh, like any scan-ins or scan-outs are looking like, and we can before actually launching simulations, we can actually see that that the conversion is correct or not. There will be some differences that is expected for sure, but uh, uh, but mostly we need to worry about at which point the the strobing is happening. Okay, the signals are not continuous. Signals
Mm.
are not continuously same, but at stroke points, they should be correct. They should be correctly matching. That's how we actually check. Yeah.
Mm.
So mostly like some of the signals, what generally I check is that reset signal or clock or scan signals or any specific signal what you have. So that you can check. Okay.
Okay.
Yeah. So even this is also packaged with the with the tool what the installation what we have uh, shipped to uh, we have shipped to Western Digital, so that we can use. Yeah.
Okay. And yeah, Nadeem, like
Yeah.
let's say if there are some errors, then how do we check it here in the DFT view?
Error in the sense the difference in the signal.
Yeah. Yeah, if there is some difference, yeah.
Okay, so first is that uh, from that visual checking point of view,
Mm.
it will be difficult to check. No,
Yeah.
not that difficult. I mean, like uh, s- so there's no one way to check. For example, how do I generally check is that I do a conversion. I check some basic signals if those are working properly or not, and then
Mm.
then I file for simulation. Okay, then I
Okay.
launch Sims and let the Sims go through. If Sims are passing is well and good. If Sims are failing, then we need to see that yeah, at which point the conversion is failing. Okay, the
Okay.
test bench simulation failure will tell at this point the failure is happening. I load that generally. I load that test bench into DFT view and compare it like how we are comparing it. Okay,
Mm.
and
Yeah.
based on that comparison, we do the further changes. Yeah.
Mm.
Okay. So it's okay. There'll be many change. There'll be many things. Uh, uh, I'm like there'll be many uh, uh, fine tuning or changes what we may have to do. So let's just try it out in your environment. Okay. So
Yeah.
yeah, that will be best way to proceed forward. Okay. So would you like to share your screen and then we can like do it one by one?
Yeah, we can do that way, or you can just take my controls and
Okay.
anyways.
Yeah. Yeah, that is also fine. That is also fine. Yeah. I'll stop sharing. Okay.
Mm. Yeah.
Yeah, let's try out in your environment.
Yeah. So I'm sharing my screen, right?
It's not visible yet.
Yeah, I just did.
Okay. Yeah, yeah, now I can see.
So now you can see that options of request control.
Yeah, okay. Okay, requesting control is disabled by the sharer company admin. It looks like I can't take control.
Okay.
Okay, no worries. Yeah, you just will navigate it through. You just start. Uh, yeah. So
Actually,
better.
I
Hmm.
don't know how to actually open that VTRAN, so that's why I asked you.
Okay, okay. Basically, different companies will have different environment to run. But
Mm.
can you do LS here? Okay, go back one step. Do LS again. Who is Felix? Felix test case. What is that?
That is some project, like
Okay,
previous
okay,
project. That's not tester right now.
okay, okay. Actually, we need to know where the installation of VTRAN is there. Okay, how do you generally invoke tool? In case any tool you are invoking, how do you invoke it?
Uh, Actually, I don't have any proper idea.
Okay,
Like,
okay, 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 okay. No worries. Can you check? Actually, uh, we need to invoke the VTRAN installation, which I had shared to Hussein.
mm, yeah.
Okay, so from there, if we can know the path, where the installation is done, then we
Mm.
can invoke DFT, then we can invoke VUI, and we can start, we can work with the configuration. Okay.
Yeah, actually, I asked Mohammed Hussain about how to invoke the file. He said he has to fire in some other way. Like
Okay.
it will take some other path, not the general path that we generally do. So he said he will
Okay.
share me later, but I think he did not do that.
Okay, okay. Just help remind him once,
Yeah.
because the config what we have generated here, that config I can share, but it's better if we generate it in your environment so that we get more comfortable. Okay.
Okay.
Just help remind him so that yeah, we can like launch the VTRAN and do our runs.
Yeah,
Okay.
yeah, I'll ask him right now only.
Sure, sure,
Okay.
sure, sure.
Yeah. And I'll mail you like whenever you are free, we'll sync up. Okay.
Sure, sure, definitely, definitely. We next I'll be free from 5:30, I think.
Okay.
Okay, if you are available at night, I'm also available at night.
Yeah, yeah, I'm available.
Okay, great, great. Yeah. Yeah, okay, then let's meet tonight then. How about like 9:30? 9:30
Yeah,
is
it will
fine?
be fine. Yeah,
Okay, great. Okay, okay, let's meet at 9:30 or around that. Yeah.
sure, sure.
Okay. Okay, so what we need is that the style file, you will obviously have that style file. Okay, the
Mm.
input style file, what do you want to convert? And
Yeah.
the VTRAN installation path. I had provided to Hussein. So uh, because that's a standalone executable file, that means it's not an official installation. Okay, it's a standalone. That's why Hussein is saying that he has to fire it in another way.
Okay.
Okay. Why he's saying that? Because in general, you would, in general, Western Digital has a wrapper, wrapper commands, wrapper script.
Mm.
You guys call that wrapper script, and that invokes the tool.
Okay.
Okay. So basically, please help get the VTRAN installation path and
Mm.
how do you invoke the VTRAN. Okay.
Okay.
And the rest we will do it tonight. Yeah.
Sure, sure. Yeah.
Okay. Okay. You have the documentations which we had shared, or I can share it to
Yeah,
you. You have it?
the PPT and one PDF of six
Yes.
hundred pages.
Yeah, 600 pages. Yeah.
Yeah.
Yeah. Okay. 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 Sure. Okay, that is enough. Yeah.
Yeah,
Okay.
okay. So yeah. Thank you,
Okay.
Naren.
Sure. Sure. Let's meet tonight then. Yeah. Okay.
Sure, sure. Yeah.
Sure. Thanks, Abhishek. Thanks, man. Thanks. Take care. Bye.
Yeah. Bye.